Hello, folks. We are picking up in part 2 of the Solid Server Boilerplate series, where I am answering a student's question on how to build a great scalable starting server for a fresh bootcamp grad that had this question, right? We have a boilerplate in our course that combines an Express backend with a React frontend that they learn from as a mono repo, but they were wondering how can they build just a solid server itself, and this is what the video is answering that question too. Again, it'll be description below will have a link to this repository, a link to the previous video, a link to the playlist, and a description of what we're doing, so make sure to like, comment, and subscribe. Let's keep going. I talked about our configuration objects. I talked about build scripts in the previous video, as well as what basic packages we're installing. Again, I talked about getting our app server starting and then building out our application with asynchronously loaded modules to build out our application. I chose to use MySQL because that's what the student in our course learned, which is MySQL, but this is easily swappable out for Mongo, Postgres, whatever you prefer. Two things from the previous video that I need to address. First, when I ended the video, I pushed everything to a repository, and to my surprise, like a complete amateur, I completely forgot to add node underscore modules into my git ignore. So the very first thing I tried to git commit, I noticed there was like hundreds of thousands, like tens of thousands of changes, and I was like, oh no, I forgot to include node modules in my git ignore. But as you can see, like I mentioned in the previous video, this is like the one git ignore to rule them all that I don't remember where I found it, but I just use it and paste it between the majority of my projects these days. It's like my go-to. But there you go. That's something I forgot in the last video. Total amateur mistake, but it just goes to show that even if you've been coding for 5-6 years, you never get away from making the same goofy little mistakes that you did back when you were a newbie. You just get faster at identifying what they are. I always tell my students that. And then second of all, I need to add some custom stuff to the MySQL pool because the config I gave was very, very bare bones. But there's something that I begin adding on a lot of my new projects, which is two particular properties to deal with time zones and dates and date times and timestamps. MySQL, the library, will try and convert those things to new date objects, which sometimes can mess things up. I'll have another link. There's going to be so many links in this description, in this video description, where I have another video covering what and why I'm adding it with examples of what it changes. But for now, we're just going to kind of go with it. And again, if you're curious of what these actually do, we're going to add it in the video description below. So I'm going to say, give me that object. There's going to be a couple custom things that I want to add to this object that will differentiate it from before. One is called time zone. I will say do the UTC time zone. The other one is called date strings, where I will include the following date strings. What this will do is make sure that it doesn't attempt to convert anything from strings to date objects or vice versa. Just give me everything as a string and I will do the conversions myself. The other thing I like to do as well is to say when the pool receives its connection, which it should be, I'm surprised create pool isn't saying that it created a pool, which is odd. Oh, because I don't think I wrote that type up here. And then I wonder if we'll have a pool. Yeah, there we go. A pool type right there. There we go. On connection, run the following code with said connection. I need to grab the connection itself, or whatever you want to call it. And then we're going to say, come on now. Fix up, there we go. Connection.query. We need to set time underscore zone, which is like a variable on MySQL servers, to be UTC 0. That way, again, we will handle all possible time zones and like date formats and date displays ourselves. This way, nothing is converted and messed up from our MySQL databases back over to our code. This is something that I recommend you do on MySQL servers, right? So in case that throws an error, we'll account for it. Let me stop it. If error, throw the error up the process, and hopefully it crashes everything here. How about you be consistent, Luke? There we go. All right, so this is just setting up some information on our connection when it establishes the state pool connection. Don't mess with timestamps and date strings. We'll deal with it ourselves. Make sure our SQL server is running on UTC 0 and call it a day. I don't think the project is currently running, so let's go ahead and run this sucker to make sure it connects just fine with those differences. Yeah, check it out. So transpiled, MySQL loaded, connected just fine, Express loaded just fine. We are good to go. All right, continuing our discussion. Yeesh. What else we need to do here, folks? Well, we actually need to build out maybe our database, our DB layer. So what I'm going to do here is go to make a new folder called DB. This is where my students will recognize this. You don't have to do this if obviously if you're using a different what's it called? A different database. Like if you're using Mongo and you establish the connection and things like that and load up everything in your loaders, instead of calling this DB, you could call it models, where you build out your models for your database. Or maybe this is where you include your ORM if you use one. I don't like using them because I like torturing myself. I like writing raw queries and practicing them, and then if I have any issues with them, I can debug the query simply and not mess with code to get around that. So what we're going to do here is make a query file, because this is where we are going to import from loaders, MySQL. This is where we have to get that pool connection, which I called it the get function, right? Because again, that's an object that we are asynchronously loading at a later date and time. So at a later time when we boot up our server. So we need to get that pool connection, which should be the state.pool that returns to us, right? From there, I also want to have MySQL do some stuff. So I will also import something from the MySQL library, and I'm also going to bring in a particular type from the MySQL library as well, which I think is the OK packet. Yeah, that's a response type from inserts, updates, and deletes that you get from MySQL. That's that OK packet, like affected rows, field count, insert ID, stuff like that. And I also want the format function from MySQL, and that should be all I need. So from here, export default a function that we are going to say it'll have a type that will default to the OK packet unless we specifies otherwise. Cool. And what it's going to have is a query string that we're always going to pass in, and then some, we're going to lazily do this here, folks, optional values of type any, because it could be a string, it could be an object, it could be an array of strings, could be an array of arrays, and I'm just too lazy to write that interface right now. Gotta love it, folks. Return new promise that will use that type, that will have our resolve and reject functions inside of it. Resolve, reject. And this is where we will format our SQL to make sure it looks good. Query values. We're going to log that SQL so we can inspect it if we need to. This way we can see it running or not running correctly. I will include this with a logger at a later date and time. Get our connection and run the following SQL query. Handle the error and results that come from this sucker. And there we go. We're going to say if there is an error, I would like you to return reject error. Otherwise, return resolve with the results of said query. Yeah, there we go. And wunderbar. Okay, so now we're going to, right, tables. And this is, again, this is my structure, my choice on how I'm doing this. You don't necessarily have to do it this way. I like to include an index file and then all of my sub projects. Here's where I would include like the name of the schema, and then inside of that is where my tables would be, right? So for example, I'll have my DB folder. I'm not going to make like a tree here in real time, but like I'll have my DB folder, and then inside of that, I'll have my query file, which will be, you know, where I set up that promise for that, so I can not have to get stuck in callback hell. This is just setting up a query utility that just helps me write cleaner looking asynchronous code by using promises rather than having to worry about callback syntax. Then I'll have a folder called tables, and from here I'll have like the project name or whatever, like join us was this particular schema, and inside of there I'll have my users table where I'll ultimately have what I need. So that's how I would do it to have multiple projects. And maybe my workout app is here where I also have a users table and a workouts table, for example. That's the structure I did in my larger scale Express server. That this is what this is mimicking, and it worked out pretty dang well. Like basically, each subfolder of the tables folder, or I can even call this projects, schemas. It might be actually a better name, or we may call this like the schemas, right? Because the point of this server is to act like a mega backbone for all projects. But again, this depends on what you're trying to use it for. If you're trying to build several at once, it'll be attached to only a single schema at a time. Then you can just call them tables or models or whatever you want, really, right? But yeah, so what I'm going to include here now is, let's say I did want to include the join us project, right? That, and then inside of there is where I'll include another index, and then whatever table we have in there to write a query for, which I think I called it join us and I called it users. Let's go take a look to make sure. Join us users should be it, right? Let's go take a look at that data. Yeah, okay, that's what I want to see. Okay, so that's where I'd also have a users.ts, and what I would do from there is import from up1 into query. I want to import my query utility from that file. From there, what I also like to do is make an interface. Now, I could make this in my types folder, but I like having my types for like a database table in MySQL as a type in the file where I have my queries written for it. So I'm going to have as interface, we'll call it users table, right? Or I'll call it like join us users, right? There we go. We'll have my types for it, which looks like I have ID numbers, email strings, and created at will be strings. I told MySQL to not convert anything. So we'll have, and again, from a TypeScript point of view, it doesn't know what I'll be selecting, so I'll make these properties optional. Enter, that's why. I was like, why is everything still erroring? Email string and created at string. There we go. And this is where I will write things like export, or rather we'll write function all. We'll take no options for this, and we'll simply say I need you to return a call to query where I will say select star from users, please and thank you. And then I will that. Okay. Oh, and I need to provide the type. That was the whole purpose of this, where I'll say this will be an array of join us user types, because all select statements with the MySQL library are arrays of objects. Okay, cool. So now I will as users from there. So we're daisy chaining the export out from this. Now I need to daisy chain this out from the join us directory over here, where I will say from that directory. There we go. And that should just about do it. So we had that basic query. Now we actually need to build out our route structure. I wanted to go through this portion here for anyone following along with MySQL, aka the student this is meant for, but just to give you all an idea of some structure for those that are thinking about how they'll translate this to Postgres or Mongo or something like that, right? I'm going to close out all these crazy files and folders and start focusing back on our routes here. So in my routes directory is our networking layer. So something I want to keep separate is my data layer, right? This is all my queries and stuff like that, which is why I separated them into their own individual folder to keep my data layer away from my networking layer, which will be the routes. Their purpose is to match paths and run some logic. And I don't want to have a whole bunch of data layer logic mixing in my route logic, because again, that gets hard to debug and it doesn't scale well at all. And I also now have some reusability. Maybe this query, this select star from users, needs to run in multiple places. Maybe it has to run from a cron job. Now I have a whole lot more reusability because I took the time to separate out a data layer away from my networking layer, which is why we're taking this approach in its setup. Okay, now for our routes, we need to build out some logic here. We need to have some logic on how to configure our application with all these routes and things like that, right? So I'm going to be building out, surprise, surprise, an index file in Yonder, index.ts, where I need to make a router from Express. As before, I have been doing this by export defaults. We'll make a function. This is basically our index router, or all of our connected routes, whether they're API or auth routes, depending on what you're planning to do with your server here, where it's going to be a function that creates its own router and simply returns it as needed, because it needs to return this router as a middleware that will be stacking here in Express. We'll simply be calling our app use router down as a function that will return a fully configured API and authentication router for us here. I'll be passing, as always, this app variable into... I was like, why is it still not highlighted? I keep forgetting the function keyword because I don't normally do it this way, but I picked a pattern and I'm going to be consistent, which is my advice to y'all. If you're going to be wrong, just be consistently wrong. That way it's easy to go back and fix consistently wrong errors. And what I'll be doing is I'll be passing this app into my other sub-routers to configure them and their routes, right? So, for example, if I'm going to have this project and a new schema for the join us schema I've been working on, it will, surprise, have its own index file. I'll be doing the same thing. We'll be importing a router, because this could potentially have several different routes on it. There we go. Well, I'll have a export default function. This is where I would be passing in my router. So let's go ahead and get that type ready. Type router from Express, please and thank you. Cool. Oh, because they can't have the same name then, can they? Oh, I think it brings in both the type and the function, if I'm not mistaken. We'll see. We'll see what happens here in just a moment. Right? Man, like I said, my fingers today are just not wanting to work, are they? So what we're going to include here is, we'll call it that app we passed in from the higher level. That'll be of type router. Okay, that did work the way I was hoping it would. This will create another internal route meant for the join us project routes that will include sub routes as well. There we go. And then we'll say that for this project, it will add a new path to the index router called join us, right? Join us. Join us. That looks weird for some reason. And it will be using this new route here, and we're going to return this route like that. There we go. So now what I can do is head back to the other index and do the following, where I can say import join us router from the join us index directory, and simply say app.use whatever join us router ends up returning to us. At least I thought it should be a function. No, because that app.use happens inside there. My bad, folks. I'm thinking about a different project I'm working on. There we go. Pass in this router app, and it'll get configured by whatever that join us function does. Again, we're choosing to write everything inside of functions for testability and scalability and speed as we go across this project here, which is why I'm choosing to do it this way. And this is where I would simply add, for all of my projects I'm adding to my server, they just get added here as a router. So there we go. This is our index router. Index router is calling a function from our join us project and its index that adds the path we want to add to our API. And from here, it needs to have another custom route. So for each table, I typically have a file for each REST API route I am working on throughout this project, where again, this will be importing our router from Express, wunderbar. And if we had middlewares and tables and things like that, that's where I'd end up writing more code here. But for now, I'm going to instead just say export default function that takes the app we've been working and configuring. And what I need it to do is simply build up everything we need it to build up. So I can say const route equals a call to our router, app.use. This will be for the path of API prefix, join us users. Again, I'm going to this, and it'll use whatever this route is configured with. So there we go. So I will say route.get on the /users, user/path, which will be just simply making an easy call to the following. Let's run our try catch, pass the error along when we get to our global error handling middleware, and it should be whatever results from our database call, which here's where I would argue that we should separate it out into one more layer of logic called services, where we do not want to include a whole lot of business logic here inside of our routes. The purpose of these routes, they're already complex enough with the way we're writing them by trying to match all these paths and methods up and things like that, that we don't want to include tons of like weird database calls or conditions and checks, because eventually we're going to be adding middleware and validation checks and things like that, and they're going to get complex as is, let alone having a bunch of stuff in the middle mudding it up even further. So even moving a couple lines of code that are simple, like for example the following. Yeah, we'll call it DB, who cares? Up one. This is where we can talk about aliases as well, because it gets kind of gnarly when we start talking about how complex this stuff gets. Where we'll go to the schemas index, and there we go. Has no default export because I chose to export it as named stuff, didn't I? Join us. Yeah, there we go. All right, so join us.users.all, which should be a function in there. Interesting. Looks like I messed up something in my daisy chain process here. Users all default export out is an object that I export out as users. If it's the object I'm exporting, then it should be. There we go. Does that fix it? No, it doesn't. This is why I do named imports, because I mix myself up on default exports as well, because I'm a goofball. What can I say? So what am I missing here? What piece am I missing? Hey, I'm a genius. My God, like I said, this is why I tend to also make a this is gonna be async. Oh, wait, there we go. This is also why I recommend we're gonna go down this path when we get there. We're gonna build out a services file that ends up taking code like this and abstracting it away one step even further. But for now, we're gonna go ahead and test. We need to be at some point actually testing our API routes, because the whole point of this question was how to build out a server. Well, and this is how I build out my routes on a server that will scale more and more. But again, these two lines of code, or this one line of code, very simple, but technically is some layer of business logic. So we can abstract that even further into a service layer that is meant to run this code and any modifications that need to happen. So if you did have some conditions or some query results that would change, or like your query would change based on some URL parameters, for example, then this code would grow from one line potentially to 10, 15, 20, hundreds. And you don't want to include all that level of business logic here in this routing layer when validation and middleware and things like that get involved. So we have a couple of choices. You'll see in some projects, this highlighted snippet of code moved to its own folder called controllers. And that's your service layer, where the controller will be the actual action that runs on a route and method. That way you'd have code that looks like this. I know it's going to be mad at me. It's fine. And you'd have something akin to that, where you'd have this logic separated out. That way here, you would have your token middleware if you had any, validation, blah, blah, blah. Like your paths will get more and more complex the bigger this gets. So this is what we're going to be heading towards at some point in time. But for now, we just want to get this up and running and testing, and then I'll come back and clean it up in a little bit, right? So that's what we're looking at for what a route might look like. And this is where I'd write out my post, put basically my CRUD operations, right? That's where this is all going to live here. And that's looking pretty good. So we now need to add this logic to our router, I'm pretty sure, somewhere. I mean, that's the whole point of this, right? So this is where I would pass in this route so it could be joined into this route, right? The app.use portion. So I need to now import users route from the user's file here. And I will say now, configure the user's route and pass in our application like so. Actually, no, we need to pass in the route because the app is the whole join us thing as part of the route, and this individual route is the one that's going to be customized with this user route now because this represents the join us route, and this represents our whole index router, and we're going to pass it in right there. So there we go. That's what we should be doing, folks. All right, looking pretty good. Looking pretty good. Okay, so now that we have that scaling up, let's go ahead and close out all these crazy indexes once again. Hopefully this ends up working here. I now need to head back to our Express loader where we're going to be configuring this whole set of routes. So I need to import them so I can use them. So I will say import my index router, because that will include both API and auth logic when we get that far. Up one, into routes, and hooray, this works. Oh boy, man, this stuff gets complicated quick, folks. Let's take a look at our index router. It is a function that builds out everything as it should. Okay, cool. So yeah, that should be all we need to import to get this sucker up and running. So back below all our set of middlewares, I'll say app.use on the path of whatever I want, like API, whatever API prefix is going to be, maybe dev or something like that. Let's use our index router function, and voila. Dang, that was a lot of code, y'all. It seems to be loaded and running just fine, so I can open up Postman and do a quick test. I'll probably have some tabs open from a different video series I'm working on. That's okay. So I'll be testing this API route right here by going to localhost 3000 /dev/join us /users get request, and booyah! Look at that, folks. One shot. And there you go. That's getting our router built up and running. And all you'd have to do is repeat this process for each new project you add to your server. I like adding templates of how to do that into a README as well. So yeah, that's how you get that on there. So, I typically don't use this as an API prefix. If there was no authenticate, like if you're building out a separate authentication service, or you're using like Google login for your authentication service, you can call this prefix /API, whatever you want to call it. I like to have different tests for my API and Postman, depending whether I'm in development testing or production testing. So what we can do is actually include a API prefix that will be /dev here in development. Surprise, surprise. Going to add this to our configuration, where I might do... It makes sense to actually make this a property called app that will have that port. We'll have to go fix that. And I'll have a API prefix that will be process.env.API prefix. Head to our app to fix the bug we have now. App.port, app.port. And then back to our Express, where we can now do, instead of just dev written directly here, I can do config.app.API prefix. And there we go. Does she load just fine? Seems to be the case. Make the request again, and we're getting all of our stuff. Beautiful. So yeah, we are now able to get up and running with queries and whatever projects we got going on, y'all. Looking good, feeling good, man. Okay, some other things we need. So yeah, always good to add comments, right? Status checkpoints. We talked about reveal real origin IP behind reverse proxies. Middlewares. Routes. And then I'll have some error handlers come in on up, right? So from here, I'm going to once again close and collapse everything, because I'm just all about that life and trying to start new things, especially, as we're getting more and more complex here. We got to have some error handling middlewares to enable our, I said I'll close everything out, go figure. This next error bit here, it sends the next error currently to nowhere. So what I need to do is make a global error handler to catch this all the way daisy chain down the line to globally error handle all my stuff in a consistent way. So I'm going to be building out a middlewares folder. Now, here's something we can argue. We could build middlewares out directly in source, Or because they're only part of routes, I could also choose to include them here in the routes directory by making a middlewares folder. I'll go ahead and take that route since they are only going to be attached to routes, so it makes sense that they're going to be appearing only here, right? Errors.ts. So here's where I'm going to choose to do the following: type import from Express, where we're going to say bring in our request, our response, and our next object, should you choose, or next function. And we're going to say we're going to have two specific exports. We're going to have one called not found handler. There we go. Where it will be request response type, and the next be the next function type. There we go. Okay. And it's going to generate a new error. Path rec.original URL not found. So this will handle 404 errors. The reason we are doing this, folks, is because Express.js has a default response added to it for 404 errors. We can see here it is a simple HTML page that can be very annoying when you're making requests and you're trying to parse JSON responses and you get an HTML response instead. So the point here is to make sure that this pre-made error response is overridden by our custom 404 handler, which is what this is right here, right? And then we're going to set an error status property to be a new one of 404, and daisy chain to the next step with our newly generated 404 error. And then this will be our global error handler. That will be the last step in the process of this whole daisy chain thing, right? So we'll say the error will be of type error. Copy these up here because we're going to also get recres next. And continuing on, next step here, I need to probably log what's happening so I can log what the error message is that went wrong for my own log's sake. Come on, Luke, be consistent. Set a status code. They're not sending a status code, just setting one to say use the error status if it has one. My God, Luke, you know what? I'm driving myself insane. There we go. Just be consistent, man. Come on, man. Just be consistent here. Use the error status like 404 or 401 if it exists, but if one does not exist, set a default of 500 as a fallback and send a response of whatever our error.message happens to be. There we go. Cool. And it doesn't matter. I could have just done like error.message as a flat string, but we're going to do it this way here. So, okay, cool. Yeah, with these two now ready to go, we're going to head back to our Express loader because this is where we're going to add them. We're going to have two different app.uses, and we're going to import these suckers to get them ready. So we're going to say import from up1 routes middlewares errors in particular. We're going to have our not found handler and our global error handler. There we go. And then now I'm going to place my not found handler there, and then my global error handler below that, and eureka, we should be good to go. Let's go. All right, testing it out. This is what the old 404 looked like. This is what our new one looks like. All right, and that's going to give us much more consistent error handling across our entire server, which is what we're going to be looking for here, consistency. Let me show you what the error now looks like if, say, the route itself failed. So rather than sending the results, we'll simply throw new error. Do I work? What am I? Do I work? Let's see what this does now. So a valid API endpoint, so it's not going to 404. We do get a 500 error with our custom error message right there. So hell yeah, that's what I'm talking about, y'all. Looking good and being consistent. Name of the game. Name of the game. All right. Yeah, that kind of concludes the Express part of the setup. Authentication. You don't have to roll with Passport. You can roll your own. It doesn't matter. So I don't think that's the scope of this video. If you do want to see that, however, then please get in the comments, and I will continue this this playlist series even further, where I add passport authentication and build some middlewares out for that and whatnot. Yeah, if you want, we can also talk about validators in more videos, but that might be kind of more. It's not more advanced. I would include them on my own server, but again, I know the skill level of people coming in this video series is like your basic boilerplate that you can add and learn from. This is already a lot in my opinion for boilerplate, right? Because boilerplate kind of implies it should be fairly bog standard, and you can customize it from there. But I think this is all pretty standard stuff, and I gave you some examples of how I would build out, since I'm not using an ORM, my schemas for each project I'm adding to this mega server, how I handle individual tables and daisy chain their exports out, how to set up the routes and scale them. But I haven't talked about yet about services, which I might do in the next video, which again, for a route as easy and simple as this one, a service would be, well, completely overkill. But again, it would be very reasonable to have like a register service for a register route logic, so you don't have to generate an ID, check their email existence, confirm their password, salt and hash it, and all that kind of stuff inside of a route, because that doesn't make sense, because this is the networking layer and that's a lot of business logic. So instead, you would have a service called user register service that would run all that logic for you, and that way, instead of having like a route that would look something like this, where you'd have a route to register somebody. This would be a post request. We can even call it the register route as an example here, where you would have to run logic like, what would you have to run? You would need to write, I'm trying to think. Well, you'd have to write out your logic to register a new user, which would be things like what? You would have to check for the existence of their email as is. So I'm trying to think, like, what am I doing? Pseudocode. If email exists, right? So you'd have to like, email exists equals find that user's email, right? You have to run like a function that would find their email address. If it exists, you would have to throw a new error, for example, because they're already registered, and then you would have to make sure that the email they're giving you, if it doesn't exist, is valid, and you'd run some kind of check on that, right? Like run some kind of regex to make sure that the email is valid, otherwise throw an error. If it's not valid, if email is not valid, is not valid by some regex test, then throw an error, right? Because that can't happen there. Then you would have to, if they had like a username, do the same thing for a username. Like if their name isn't valid, like maybe you have a username field going on as well as their email. Generate like a new UUID for their ID for the users table, if that's what you're going to be doing. Hash their password. What I'm saying here is like, that's going to be a lot of business logic that's going to be existing in a route that, like I said, with stacked middlewares and validators becomes quite cumbersome. So instead of having all this logic in your route, make a services directory that has either subtables or subfolders if you need them for projects. And inside of those, you have a function, for example, that could take their email address and password, if they provide one, and just do the following. User registered, where we would say register user, and that's where we'd pass in the email and password they're trying to register a new user with, and then whatever that response happens to be, boom, we send it out like that. And that way, all that logic gets moved to that service that helps keep business logic away from our networking and routing logic right there. That's the whole purpose of a services file, just to move business logic out to keep our code more scalable and much cleaner, right? So if I'm debugging why it's 404ing or something like that, I can head to the route for the actual logic. If I'm wondering why the code inside the route's not working via a 500 error, I would head to the associated service function to go debug that stuff there. If there's some problem in the query, I head to the database layer for that. So we have our data layer represented by the DB folder. We have our networking layer represented by the routes folder, and we'd have our services layer represented by the services folder, right? That's where our route logic, our actions, our controllers, the function that runs on this API endpoint. I believe it's called the action that runs our actual code, right? That can also be moved to the service layer if you wanted it to be. But yeah, I think that's a pretty okay stopping point for now in this video series. Yeah. And I'll watch the comments, and I'll even, again, I'll also be primarily looking at what my student in Discord was asking me to see if this was okay for a solid boiler starting point. I can't think of much else I need to include here because everything else I'm thinking of would be adding tokens and bcrypt, but again, maybe you're not adding auth to this project, so that's not something you need to bother adding to this whole configured boilerplate here. So I'm going to end the video here, but I will make one more. I will go over optional stuff, maybe even two more optional stuff, such as a new logger, because console log can be blocking and kind of slow, and it's not going to help us in production. So we're going to add a custom logger that can actually move things to a text file or into a database for us, so we can look at actual error logs if we have the ability to do so, and maybe adding auth in the second video series if you want to do Passport to learn it from here, so I can keep on juicing the reels and making more videos, which I like to do. So that's to be a ta-ta for now. Check the description below for all relevant links. Make sure to like, comment, and subscribe if you want me to continue this series even further. Just let me know, and I'll be happy to do so. But bye.